In chapter 6, the first part of chapter 6, the first section is friction, and we've been doing examples of that. Second part is motion or resistive medium, which is very similar to frictional motion. But before we get to that, I'm going to take the class actually slightly out of order. I'm going to talk about the third section, and the third section is centripetal motion or centripetal force. So centripetal force. So you've heard of centrifugal force. Well, that's not really what we're talking about here. Centripetal force, we know that if something is moving in uniform circular motion, okay, so we have R, we got velocity, we got some kind of mass object going around, and it's going around in circular, it's going around in a circle, then we know there's a centripetal acceleration v squared over r. Well, we know that force equals mass acceleration, so that means there has to be a force inwards right here, okay, pulling it inwards. That is the centripetal force. So that's going to be equal to mv squared over r. Okay, now what's this centrifugal force that you hear about? Because you hear about that a lot. Well, if you imagine that you have somebody and they are slinging something on a string around their head. Okay. If you let go of the string, the object goes flying off somewhere. So it looks like someone had taken a giant force and yanked it out of the hand. And so it looks like there's an outward force. In fact, the person has to constantly be pulling the entire time. So it feels like Newton's third law, it feels like there's a force outwards. Okay. And so that outward force is the centrifugal force. The inward pull is the centripetal force. Now, in physics, we normally think of the centrifugal force as not really a force. It is a pseudo-force. A pseudo-force is something that looks, feels, and acts like a force, except it's really not a force. It's sort of a force, but it's the centripetal force that's actually happening. And you know that because as soon as the person lets go, the thing doesn't go straight outwards. What happens is it goes in a straight line. Now, as it goes in a straight line, then the person that was swinging it around, their hand is still moving when they let go, and so the distance between the hand and the object keeps increasing, so it looks like it's being pulled straight outwards, but it's not being pulled outwards. It's really a lack of being pulled inwards, and so Newton's first law kicks in at this point and says that if there is no force acting on it, it will move in a straight line. Similar when we did the example problem of the space station. Okay, so in the space station, as the space station was rotating, then there's a centripetal force here that is pushing inwards. But if you had an astronaut that was hanging on to the outside of the space station here, then it would feel as if there's a pull outward on him, because what's happening is the space station's pulling inwards and he has to pull back in order to hold on. And so if you let go, the astronaut is going to move in a straight line. Well, actually not that way, but the astronaut will move in a straight line. But as the station rotates, then the point here, point there, point there, point there, okay, and so it looks like, if you were for an astronaut on the inside, it would look like the person's going straight outwards. And so that's why the centrifugal force is often portrayed as an outward force. It's not. It is in fact an inward force. And the centrifugal force, the pseudo force, it's what looks like an outward force. And so I just thought I'd point that out. So this is the basic idea of centripetal force.